Hi everyone, in this video I'm going to be talking about what is hydrogen bonds. So let's start. Now before starting with what is a hydrogen bond, let's first talk about what are polar covalent bonds. Okay, so these are the values of electronegativity of the first and second period of periodic table. These are the values on the Pauling scale, and it is quite clear to us that lithium is having the lowest electronegativity, whereas fluorine is having the highest electronegativity, right? So what is this electronegativity? Electronegativity is nothing but the tendency of any atom to attract the shared pair of electron toward itself. So we know how a covalent bonds we have sharing of electrons, right? So I'll just explain to you with an example. If I just draw a covalent bond between carbon and oxygen, okay, then the shared pair should lie exactly in between carbon and oxygen. That should be the case in the ideal case scenario, right? But as I can see, oxygen is much more electronegative than carbon, which means it is going to attract the shared pair of electron toward itself more, okay? Which means instead of lying in between C and O, the shared pair is going to be somewhat closer to the oxygen atom, because of which there's going to be a polar situation created, which means poles, negative and positive poles are going to be created, and oxygen is going to have a negative polarity, whereas carbon is going to have a respective positive polarity. Okay, this kind of covalent bond in which we have poles created because of difference in electronegativity of the two combining atoms, these are called polar covalent bonds. Okay, now, if we on the same lines, if we just compare hydrogen bonds, hydrogen, as you can see, is having the very low value of electronegativity of just 2.1. Okay, if I just draw a comparison between hydrogen and fluorine, okay, let's say we draw an HF bond, then again we would expect the shared pair to lie in between H and F. Okay, but because of huge difference in polarity and a very high electronegativity of fluorine, the shared pair will lie much more towards fluorine, and hence, because of that, hydrogen will have a partial positive charge and fluorine is going to have a partial negative charge. Okay. Now, this is a charge situation or polar situation which is created. Please remember, these are not ions like cations and anions. No. Okay. These are just a polarity which is created, which means a respective polarity of positive and negative which is created. Now, if I just place these HF bonds together, what do you expect? Because of the placement of these HF bonds together and there's a polar situation which is created, I would expect a kind of attraction between the positive and negative charges, okay? Which means a kind of attraction between two different molecules of H and F, okay? Because of the positive and negative polarity which they hold, right? And this, my friends, is called a hydrogen bond. Okay, the most important thing which you guys have to remember is hydrogen bonds only exist between electropositive hydrogen and nitrogen, oxygen, and fluorine, which means only hydrogen and NOF. Okay, just remember this mnemonic as NOF, and only NOF, hydrogen with nitrogen, oxygen, and fluorine, can only form a hydrogen bond because of high electronegativity difference which lies between hydrogen and the atoms of nitrogen, oxygen, or fluorine. Okay, now to give a few examples, the most important example is water. So water is a universal solvent having hydrogen bonding between two different molecules, and it exists between atoms of oxygen and hydrogen. Okay, again we have alcohol in which we have hydrogen bonding. This is again an OH kind of hydrogen bonding between two different molecules. In case of carboxylic acids, again we have an OH kind of hydrogen bonding. In case of ammonia, we have an NH type of hydrogen bonding between two different molecules. If we just mix ammonia and water together, we will have again an OH or NH kind of hydrogen bonding which can exist. Okay, so just to sum it up, I can say that hydrogen bonds are strong bonds. Okay, so of course we cannot compare them to the stronger bonds like ionic and covalent bond, but they are stronger bonds as compared to the London forces and the dispersion forces. Okay, and they are strong enough to confer liquid properties to any compound that they have. Okay, for example, water is a liquid. Okay, glycerol, glycol. So again, the amount of hydrogen bonding, as it increases, liquid can become more and more viscous. Okay, and most compounds which have hydrogen bondings are either liquids or solids. They are possibly never gases. Okay, because again, hydrogen bonds are strong bonds. Next, we have types of hydrogen bonding. Okay, so now in this example, this is an example of orthonitrophenol. Okay, so here we see a tendency of hydrogen bonding, or a capability of hydrogen bond between oxygen and hydrogen. Okay, so just if you look carefully, you can see that this hydrogen bond exists between oxygen and hydrogen of the same molecule, right? So hydrogen bond exists between oxygen and hydrogen of the same molecule. These kind of hydrogen bonds are called intramolecular hydrogen bond, right? But in case of paranitrophenol, okay, there is no scope of hydrogen bonding inside or within the molecule. But if I just keep two different molecules together, now I see a scope. Okay, now I see a hydrogen bonding which can exist here, right? So in cases like this, where I have hydrogen bonding between two different molecules, okay, that kind of hydrogen bonding is called intermolecular hydrogen bonding. Okay, so before ending and concluding this topic, I just have one question. Which do you think has a higher boiling point, the one which is intramolecular or the one which is intermolecular? So you can just pause this video and think about the answer. The answer to this question is that, of course, if you just look at it carefully, in case of intramolecular hydrogen bonding, there is hydrogen bonding within the molecule, right? So there is no force of attraction which is binding the molecules together. Okay, so there is nothing which is, you know, binding different molecules together. The molecules are discrete. Within the molecules, you are having hydrogen bonding, but nothing is binding the molecules together. Whereas in case of intermolecular hydrogen bonding, we have a force hydrogen bond which is binding different molecules together. Okay, because of which intermolecular hydrogen bonded compounds will have a higher boiling point. So I hope this topic is clear to you. If you have any doubts, please comment that down below. For more videos like this, follow this page and stay tuned for more.